Hey guys, what's up? This is Tim, back again with another video. It's been a while that I uploaded any tutorials, but I figured this would be interesting. Lately I've been working on my own personal teaser film called Tether, and it includes a lot of electricity type of effects, so I figured it would be interesting to do a little video on how to set up electricity. Because the thing with electricity, it's not too hard to do the initial setup, but it's nice to have a controllable setup which you can customize the look. And it's also the hardest part is basically just getting it to look right, I guess, instead of just having something. Because basically what it is just it's like splines moving around, but to get them to feel and look like electricity, that's where it gets harder. So this is just one. There's some electricity on this thing. This is not final, obviously, still, but there's the electricity jittering and stuff. So that's we're gonna make an asset, a digital asset that's gonna do something similar. So let's start by creating a sphere, make a polygon sphere, give it some segments, and let's put down a null and immediately make that into a subnet. This is just gonna be our digital asset, and it will be easy to already from the beginning have something which we can add our parameters on. So this is gonna be our electricity generator. There we go. So now we can just we can put all the controls in here, which will be easier. Alright, so if we go in there, just call this in, I guess. Let's start by dumping down a scatter node. So put down a scatter node, and we're gonna turn off relax iterations, and for the force total count we want to have a control. So let's go to our subnet here, go to edit parameter interface, and maybe let's just drag it in there. So I can go like that and call it amount. There we go. Let's just put it to 10, and let's copy and paste this scatter thing. So now we have two. So okay, let's first just offset one of them just slightly randomly, and now let's merge them together. And then what you're gonna get is just a couple of points, which you can control here how many it is. Maybe turn down the max to something like 50 or something. So we have a more interest, a better working slider. And now what we want to do is we want to create an attribute wrangle after the scatter and call it and say at ID, at ID is at point number plus 1. We want our ID to start at 1. Now we're gonna have IDs on all of our points. Call this set ID. Copy and paste this, and do the same over there. So now we're gonna have double IDs, which is if you do a particle bullet sim, that's not something you want. But over here we can use it if we put an add down to go to polygons by group, set it to by attribute, and then put ID. And as you can see, now we have lines connecting each of the points. Now obviously this is not doing anything, so basically what we want to do is we want to be able to offset this seed thing. So let's make a slider for speed. Oh, this is just gonna control our speed. Right, so first what we just want to do is we want to if we put this to add time, as you can see this is gonna jitter around quite fast, just gonna display our time. But if I'm gonna put rint, round to integer time, now you can see it's gonna move every second. So it's gonna change every second. So this already gives us a little bit more control. But now what we can say is we can take the speed, copy the parameter, we can say time times our speed. So now if we increase our time, you can see we're still gonna get like the jittery movement that electricity has, but we still have control over like how many times a second it will jitter. Like if I put it to 2, it will be about 2 times every second. If I put it to 24, it will be every frame. So it will just be our like little offset thing. So let's also put that in the second scatter. Let's copy it correctly. There we go. But now if we're gonna go back, now as you can see, no lines are being generated because the seed outcome is exactly the same. So what you can do is you can add a random number here. Now this is one we're gonna get, but obviously we also want control over like maybe our iteration. So what we can do is like make something called seed, and let's go to the first one and add our seed to there, and then on the other one let's maybe just multiply it by the seed or something. Not sure if that's going to work, but let's see if that's going to work. Yeah. All right. So now we have a seed control. So now this one ends up at 19 here, and this one ends up at 88. And now we're getting nicely. Now we have a nicely controllable electricity type generator. Alright, so that's the first part of this. Obviously we can also, like if we want to make it a little bit more interesting, we could say we want a little bit of offset inside like the second one. So what we could do is, like, if we, instead of doing this, we can also say we're gonna do the time, and we wanna maybe, like in the second one, we'll do the time times 1.2 or something. So now there's gonna be like this offset in like the 2 branches. So we can create a control for that time offset. Like you don't have to add every of these steps, but like this is just all the stuff that makes it feel more natural. So you don't have to add the time offset thing, but it might be a nice thing. So now we have a control to have like a more kind of offset type of thing. Now one of them will just jitter like with this one, and then the other one will have a slightly different value, so they won't so they won't all change at the same time, which can be quite interesting. All right, so that's the first part. Now let's move along. So now what we want to do is we want to resample this, because if we're gonna look at our, no, we don't want to resample that. We're gonna look at our lines. As you can see, they all only have like 2 points, which is not really yeah, really what we want, to be honest. So if we put down a resample node, we're gonna get like a bit more points. Let's maybe like this is fine. Alright, so what we want to do is we want to now curve it around our initial object, which is this one, obviously, because this is just moving through it, which is not really that useful. And by the way, let's also make a let's just visualize our object here. So let's just merge it into here, and then if we're gonna go to this thing, if we put it to ghost, then we can at least see our original object. Let's go back to here. Yeah. All right. So what we want to do is we want to use a ray sub, and this is just going to ray trace our splines to the original input geometry. So maybe route it around. By the way, you can hold Alt and then you can like route stuff around like this, so it looks more fancy. All right. So if I put a array and then put to minimum distance, and let's make output null, else we're gonna see the guide geometry. And now you can see it, it curves around the sphere. So that's yeah, that's something. But wouldn't it be nice if we had like a control to have like these bulge, bulge off from the surface? Because right now it's not doing anything. So that's something we wanna look at. And another thing we wanna look at is maybe like some of these are like quite long. Maybe we wanna have a control over how long can they maximally be, because maybe there's gonna be an instance where it has like it's gonna be like all the way across, and you don't want it to be that long because it might just look weird. So you might want to have a control to like remove the by the max length. So let's first add that in. So put down a measure, override the name and put it to len. Now we're gonna get a primitive attribute called len, which is the length for each of the primitives. And now what we can do is obviously we can look at the length and then say, okay, we want to remove it like if it's greater than a certain amount. So what we first need to do is actually promote. I just promote it to a point attribute, so we can just use a point wrangle. Primitive to point, and we want to promote the length. So now we're gonna have it as a point attribute. And now we can use a point wrangle to delete it. So let's remove len. And also, if you're new to Vex, like I'm not really that great at Vex myself either, but like for stuff like this, it's really quite easy to just use Vex. It's just simple lines of code, and it's much faster than doing stuff like this into VOPs, because we're gonna do an if statement, and if statements in VOPs are just slow. Slow to build, that is, they execute quite fast. But basically what we can just say is like, if our len attribute is greater than, and then let's make a channel, so channel float, so chf is greater than the max length, then the curly bracket thing, then we're gonna do remove point. So I want to remove a point from the first input, which is zeroed input, and put the add point number, and then close this thing. And we forgot a little bracket there. And then we can click this to create a slider. And now let's put max length just to something like this. So now you can see we can remove them based on how long they are. And let's change these controls to max length to be maybe like 5. And let's add it into our little control scheme over here. Maximum length, maximum effort. Just kidding. Alright, so now we have just a yeah, little control scheme. So maybe we want to cut them off at like 2.5, which seems like a decent decent length, maybe a little bit shorter even. Alright, so now we have this control. So now we want the control to have them like bulge out. Alright. So let's think about how we can do that. So basically we're gonna have our sphere. And our sphere, and does it work? Yeah, that works. Okay, our sphere is gonna have normals, and as you know, you can displace along a normal. What we can also do is we can displace our original geometry along the normal of like our original input geometry. So we can have like 2 inputs. So if I'm gonna do an attribute VOP, just call this displace along normal. Right. And let's put this one in the second input. Let's go in there. So what we want to do is we want to basically transfer the attributes from the second input to the first input, and normally you have an attribute transfer, but basically what an attribute transfer does as well is like it's a point, it opens a point cloud. So it's gonna look at every point, and then it's gonna look around the point in a certain radius, and do something with that. Well, we can also do that in VOPs. So let's do a point cloud open. We're gonna do a point cloud on the second input. So there we go. We want to sample our point position. So it's gonna look at like if we have this point, it's gonna sample around this point in whichever radius we put here. Now we're gonna do a point cloud filter. In the point cloud filter, we're just gonna say which attribute we're gonna look over. So we're gonna look over the normal, obviously. So we're gonna look around this point. And I'm thinking I'm forgetting something, by the way. Before we do this, we have to have one more step we need to do, by the way. Sorry for that. So, because no, by the way, let's just continue this thing, and then I'll go and show you what's gonna go wrong, and then after that we're gonna add an extra thing. So if we're gonna do displays along normal, we can say input the point position, and then we're gonna put the this normal, and then we're gonna put it in here. And this is obviously still not gonna do anything, but like if we have a displays amount, you can see it's gonna offset. But you can see it's gonna offset in its entirety, which is the problem I was talking about before. So what we need to do before this is we need to create an attribute for each of the splines, which we can work with to determine how much they're gonna offset. So, and like it was in the words, for each one of them. So what we're gonna do is say for each connected primitive, or just for each primitive, by the way. For each primitive should be fine. Alright, so I'm gonna go in here and put it to single pass. We should, yeah, you can see we're gonna get each of the lines. And now what we wanna do is we wanna make an attribute for each of them, which goes from 0 to 1 basically. So what we want to do is we want to say our float value of width. So we're going to create an attribute called width. We want to take our point number, and we want to divide it by a float by the total number of. By the way, we want to do our float point number. We need to create our current point number into a float pt_num. Let's put it in curly brackets, and we want to divide it by the number of points with 1. And why is this erroring? Float. Wait, let me num divided by. Confused why this is not working, because if we're gonna do it like this, it's gonna end up at null, at 0, because this is not the float value. So we gotta float that one. Yeah, and then we're gonna add one to that. No, it should be -1, by the way. Alright, so numpt -1, sorry. So now as you can see, we're gonna get a 0 to 1 value on all of our points. So let's get set width. And the width attribute is something we're gonna use in quite a lot of places. Anyway, so if I'm gonna go over here, you can see we're gonna have this for each of our splines. So now we're gonna go in here. We can bind our width attribute, and we can put down a ramp parameter, and this is gonna allow us to ramp the width of our of our offset. So let's put the ramp in the amount. Let's promote the scale. Right. So now I'm gonna go over here, and now as you can see, I'm gonna have a ramp which allows me to control the bulge of this thing. Easy, right? And then I'm also gonna have this scale. So this is something we're gonna want to have in our little digital asset thing anymore. So let's start splitting this up into folders maybe, which will be easier. So let's call this generation settings, something like this. Do a second folder called shaping, I guess. And in the shaping we want our ramp and we want our offset. Call this bulge and the bulge scale. Right, so now we're gonna have controls over here. So now we can offset it a little bit. So now we have our very basic jittering around kind of thing. Obviously arcing is not always the most realistic kind of thing, but it helps us selling the electricity type of look. It just helps giving you control over what you want to do. Alright, so move along. So now what we want to do is we want to create an attribute fob. We want to start add noises in here. So add noise. Alright, so next step, adding noises. So let's do an attribute fob. And here there's some choices which can be made. There's multiple noises which you can use, obviously, which I showed before. Like you can have a like a really archy type of thing, and the more jittery type of thing. You can combine them if you want. So let's brew down a turbulent noise for now. Put an add it to our current position, and now we're gonna get a little noise, as you can see. So as I said, there's multiple types of noises. So there's also the anti-alias flow noise. So let's also put that one. And if we're gonna put that in here, let's put down our speed to 0, by the way. Now it's you can see it a little bit easier. So the anti-alias flow noise has a flow attribute, which is this one. You can put it into time, and you can see it's some sort of a it's a looping type of noise. So what you could do is, like, you can multiply constant, like. So this is something you can use to create this type of arc type of effects. It depends on what you're doing. I personally don't really like that type of look, but like for some stuff it's more useful. Like I went more for like a jittery type of thing, so I didn't really use it. What I did is I just put a offset in my turbulent noise, I think. Now we're gonna get more like this type of look, which is a bit more random. It doesn't loop. That's just something I prefer personally. But of course you can like see for yourself which type of look that you like. You can even create like a switch, and like that way you could like switch between flow noise and that one. So maybe that will be that will be nice to add in there. So let's just keep it in there, just so we have a little bit more control, I guess. So go in here and let's start making a folder for big noise. All right, and in the big noise we're gonna say, okay, which type of noise do we want? So let's make a menu. Where is it? Ordered menu. And in the menu say, okay, we want turbulent noise, or a flow noise. Right. So now we're gonna have a noise setting there, and basically what this is just gonna output is an integer, so you can just like paste the references in there, and it will allow you to switch the noise types. So that's pretty straightforward. And all of the other stuff like the roughness and things are, we can just like take them out here. Frequency, offsets not necessary. Oh, let's promote amp roughness. Let's take these out. And also connect them to frequency over here and amplitude over there, and roughness also needs to go over there. Which might also be nice, by the way. Let me just try it out. Maybe this is better than just having a linear switch. Maybe a mix would be nice. Let's see what this does. So now we have a control to mix them, which is, yeah, I guess this is maybe a better option. Let's just go for the mix. I guess that's gonna be nicer. So let's go noise mix. Just adding things along the way, man. There we go. Just put it 2.5. And by the way, we can also just drag it in, by the way. It's maybe easier. Let's mix. All right, and also thing we wanna be able to do is, let's remove that multiply and add a new one in here. Promote parameter, and let's go out of here, and then this is going to be our speed. Noise speed. There we go. And this is going to be quite fast, as you can see, but if we put it like lower, and now we can mix. And isn't that nice? Lovely. All right, so that's basically adding noises, but as you can see, it's moving erratically away from the surface, and nobody likes that. So what we can do is, again, we can bind our width in here, very versatile attribute, and multiply our output of our noises. So let's take this and just multiply it by our width and put a ramp parameter. Put it to spline ramp. And now we can like have control over where it's gonna do the noise thing, basically. So if you can, like, I'm gonna put it like this, and they're gonna fly all over the place. And you're gonna have to decide for yourself if this is something you want to promote to like a top level or not. For this file, I'm gonna do it anyway because it's the file you're gonna be able to download, so it might be useful You can always remove it if you want. So let's say put it in here and call it noise stick ramp, I guess. Oh, we need to change it here, of course. So as you can see, now we have this control to do this thing. But for now, let's just keep it like this. But now we at least have a kind of a basic control for that. And let's also add our like noise values. So frequency, amplitude, and roughness. All right. So, all right, let's move it up, and then maybe we can increase the speed a little bit. And also, because it looks weird, let's increase the speed of our whole setup. So this is already starting to look a little bit like electricity. As you can see, this is all pretty jittery, and it's kind of on purpose, because we're not gonna use just one. We want to have multiple noises, basically. So what we want to do is we want to create another attribute swap, and this one is you can also copy it, but then the values will get taken over. So let's just make a new one. Let's first do a resample, and now what we want to do is we want to resample the whole thing, so it's gonna have a lot more segments. And now let's do another attribute swap. Let's create an interface here with small noise. There we go. And let's, by the way, let's copy this and then just remove other parameter stuff. So let's just delete all these link parameter crap. And I think we can even remove the ramp, maybe. So in this case, it's nice to not have the ramp. Maybe we can add it back in later, but for now, right, let's go in here. The frequency and the disk is gonna be a lot lower, so maybe like 0.2. It's gonna be like, we want it to be rough. And you can see we're starting to get some nice electricity type of look. Let's dump down the bulge a little bit. And as you can see, this is starting to get somewhere. This is already pretty decent. So now we have controls over our big noise. Let's go to our I guess I called it Nick noise. Let's call it big noise. Big noise is probably better. So we're gonna have some controls. So let's say we're satisfied with this for our main branches, but obviously if you're gonna have electricity, it's also gonna have like smaller branches. You're probably, like, I cannot really point them out here because they're just on random places, but what we want to do is we want to have controls over like separate arcs which are coming from the main arcs. So because now it's just some base splines, but we want like having extra stuff come off here, which is gonna connect either to the sphere or gonna just point out into nothingness, and obviously you're gonna have controls over that. So let's start building on top of this now. Alright, so let's call this. Why does it might be? It's this weird big in Houdini. Sometimes the thing stays up. Anyway, big noise, small noise, and alright. Let's put a null and call this out base. And there's this weird offset thing. Maybe do our width ramp here anyway, because apparently it's still offsetting a little bit weird. So I guess maybe we still want to keep the ramp in there, so just keep it like that anyway. So let's delete all these things. Bump up the frequency. And bump up the roughness. Alright. So, alright, let's add it into the small noise. Frequency, amplitude, roughness, and which is the last parameter? Speed, I guess, right? And the ramp. The ramp. Why doesn't it want to? That's weird. Okay, that's very weird. Alright, let's just get a ramp in here and then just link it up, I guess. Alright, so let's just put it like that, and then copy parameter and just paste it on there, and then that should also work fine. Let's call it ramp. Ramp, whatever. Alright. So now what we want to do, and put it like that maybe. Right. Now what we want to do is we want to start scattering points on these lines and to make like secondaries. So let's put a folder in here. Got secondary. Yeah, there we go. And let's start scattering points on there. But before we're gonna do that, we want to have control over where do we want to scatter those things. So let's go in here, bind the width again, not bind, width, and bind export, width, and do ramp parameter. Do a spline ramp and put it like that. Right. Scatter where, I guess is a good name. Alright, so let's after that put a scatter. Turn off relax iterations and put it to width. So now as you can see, it's gonna scatter everywhere, but we're gonna have this attribute which we can use to like say, okay, we don't want to scatter like on one side of the electricity. And for maybe like this setup, this is not super useful, but like if you're gonna have like lightning hits, for example, like and they're gonna hit like the ground, then you wouldn't want maybe like arcs shooting off from the top. Maybe you only want them for the bottom. So it's more if you're gonna have like a setup like that. That's mostly why I'm building it in here now. So let's in the secondary put the ramp, scatter where, scatter ramp, scatter ramp. There we go. Secondary. All right. So now what we want to do is wanna like say, okay, we want to copy to the point. By the way, let's maybe it's nice to only have them at the end for now. Let's do it here. All right. To copy the points, and what we want to do is we want to copy a line, and we want to severely decrease the amount of secondaries for now, and we're going to add that into the secondary settings later. So now we're going to copy these lines, but obviously we want to randomize where they are moving. So let's do an attribute randomize, put it to normal, and put it to inside sphere, and now they're gonna move everywhere. And now what we want to do is we want to put a group, and we want to group one of the points, and I always forget if I need the first or the second one, so I'm just gonna put, I guess, a 0, and then we're gonna find out if that's correct or not. Call this array group, and let's see if this sticks nicely. So that works fine. So now what we want to do is we want to be able to array our top of our thing to the bottom part. So let's put array, and let's connect it to there, and then let's reroute it, put it to minimum distance, and then put it to the array group. And I guess I chose the wrong one. Maybe it's gonna be the one. All right. So I changed the ramp down here, and it should be group 1. And I decreased the size here a little bit of the length, but what we actually want to do is we want to create another attribute wrangle, and we want to randomize the scale of the secondaries a little bit. So how we're going to do that is do at p scale is we'll do it like this: float random is rand at point number. So we're going to create a random a float value of random, which is based on the point number. And we're gonna say at p scale is fit 01, fit 01, sorry. I'm Dutch, so 01 is Dutch, so the more you know. Fit 01, and we wanna fit our random between min and general f max, and now we're gonna have these controls, and maybe we want to do like a multiplier for this. So it's gonna be like a total scale multiplier, which I always like having. So this is just overall scale multiplier. Alright. So, okay, so basically what I did then is you're gonna put down an array. And you're gonna put it to the original geo. and put it to minimum distance and put it to the ray group. And now if we're gonna merge this together, then we can see what's going on. Now you can see we're gonna have these secondary strokes raying to the surface, and of course we still have these controls to say where they're gonna be, and they will always stick to the original source geo, because they're scattered on it, and they're scattered based on the width attribute, so they should stick in the correct place. So let's double check that. If we're gonna turn the speed to 0, now you can see they stay in roughly the same place. It does jit around a little bit sometimes, but overall works pretty good. So then what we want to do is, maybe we don't want, and by the way, let's start adding these controls now. Maybe that would be a good idea. So secondary would be, okay, we want the amount, maybe we want like the seed, and what more do we want? We want the P scale, let's add the P scale attributes. Alright, so now we're gonna have all these controls. Lovely. And now what we also want to do is we want to be able to say, okay, we don't want every single one of them to stick to the surface. Maybe we want some to just randomly stick out. So let's do another attribute rank 1. You can also use a split for this. I'm just doing it in a wrangle. So I'm gonna do float rand ID is the random based on the prim num. Now we're going to get a random based on the prim number, and if the rand ID is greater than channel f remove, then we're going to do remove point, and we need to close that. So now we're going to have a control to remove that, and we're going to copy this, paste this, link those values together, and just change this up. Right, so now one of them is gonna be rate and the other one is not gonna be rate. I'm gonna merge it together. Now let's also just check how it looks. Merge that together. So now we're gonna have, like, some of them are gonna stick out. So if I'm gonna do it like the one side, like all of them are gonna stick out. If I'm gonna do the other side now, they're all gonna array to wherever. So that's another control which is nice to have. So let's call this, let's put it in here, call it stick out, stick out, put it underneath, I guess. Alright, so let's remove this one from it, and now we're gonna start adding some noise stuff again. We're gonna need to resample all of this stuff, so we're gonna need to have more points, obviously. Alright, so now what we want to do is we want to be able to add noise to this again, so we can go to the top here and like copy paste our width attribute thing again. Now we're gonna get width for each of these things. And now let's grab one of our noises. This one should be called small noise. And go down here. Let's add it in. And let's remove all of these. Controls. There we go. Right. So now we're gonna have controls again over how much it's gonna move float. Like maybe I don't mind too much if they're gonna like jitter in the bottom across the thing. And yeah, that looks decent enough. You can make differences between the big noise and the small noise here again. So let's call this big noise. Let's decrease the frequency and increase the amplitude a little bit. And we definitely don't want as many secondaries as we're having now. Maybe like 7. Alright, so big noise and then add a small noise. Just gonna have like much higher frequency and maybe like a really small amplitude. Let's call a resample. Let's put a resample in between here again. Put this to 0, 1. This is gonna give us like the really small jittery type noise. Let's go in here and just crank up this thing. So that works decently, I guess. So let's add these controls. Okay, so secondaries are gonna have another control here for big noise and another control for a small noise. And obviously maybe you don't want all of these controls because these are going to be quite a lot of controls. Maybe you only want the small noise control, but you can just remove these from your setup. I'm just showing you what's possible with all of these options. So with the big noise, just again throw all of the parameters in there. And this was time, right? Yeah. Speed, not sped, speed, and small noise. Speed. There we go. Now we're gonna have this thing. Time to start merging this stuff back together. And obviously these are gonna be the secondaries, but you can go much farther. You can also go like tertiaries. So if you want, you could like duplicate this setup and do it again on the secondaries. So you can like create branching structures. Alright, but for now just let's just move along. And another thing which I forgot to add, by the way, because as you can see now it's really sticking around here, which is quite not very organic. So we're gonna go back to the top. We're gonna go to like where they're all scattered, and let's add one more thing here. Let's add the noise. Let's add some turbulent noise and put add. And export it to the position. Now they're gonna all be offset and stuff, but we're gonna fix that. So let's do the offset is gonna be the time. I'm gonna have this multiplied by a certain value, and since we're already having a speed parameter here somewhere, so it's gonna be that one. We're gonna, or we can also just copy it from here. Copy parameter, promote this, and space relative references. So now they're gonna move around a little bit. And since we're gonna array them here anyway, doesn't really matter too much, like that they're moving around on top here, which is fine. You can also array them before, but not really that big of a deal. And if you can set extra controls for all of this, or you can just leave it in here. But like overall, if you're gonna go to the end, as you can see right now, it's a little bit less static. And if you're gonna increase this, and they're gonna walk a little bit more. So maybe we wanna still add it in. So let's go to attribute vault generation settings and call the point walk, call it point walk or something. Point walk and point walk. There we go. Alright, so now if we put it to 0, then they're gonna stick, and then if we're gonna put it up, then they're gonna have some point walk going on. Alright, so that's basically generation of the electricity itself. Let's create an output, and let's create it on the proper spot. Right. So basically now we also want to render this, obviously. So let's start going into rendering. And by the way, like, you can add more controls if you want. For example, if I'd want, because that's something I had in my own setup, I mostly spawn them where it's bright, so I'm not spawning them randomly. So for example, what you could do is you could say, okay, I wanna use a density attribute, for example. I want to use for example, like color. So in that case, what you could do is you could have, like, you could like, if I'm gonna paint in here now, then now it's only gonna scatter them in there, and then when I go completely to the bottom, now it's only gonna use them over there. So that's a control you can build in if you want. So let's start adding that control in there maybe. So what we want to do is we want to scatter based on the color. So what we want to do is, alright, let's first just make a paint sub here, and let's just paint a little bit in here. So let's do background color black, and then make it a little bit white here. And then obviously we want to be able to set it to a density attribute, call it CD. I'll let CD for here, but obviously we want to be able to have controls in here. So go to the add parameter interface thing, and let's say, okay, we want to call this spawn by attributes. Spawn by attributes. And then we want, so this is going to be the toggle, and then we want to say which attribute. So attribute. and we only want to have this one visible when this one is toggled. So how we can do that is gonna go in, and this is, I don't think this is pretty this is common knowledge, but this is quite interesting. If you go over here, you can hide when a certain value is toggled, and this is not using vex. This is, I don't know what it's using, HScript or something, some weird code which you don't use anywhere else. But we can say between the curly brackets, like if this is 0, and then if we click apply, so now you can see it's gonna only come up when we're gonna tick that box. So that's quite nice. So let's do spawn by attribute, type cd, and just copy parameter, paste relative references, copy parameter, and paste it in here, and also do that on the other side. And I guess I already did that in my previous recording where stuff went wrong. Ha 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 ha. Alright, let's paste relative references, there we go. So now it's only gonna scatter. Let's go to the first view again. Now it's only gonna scatter on there, but there we have kind of a problem, because if we're gonna disable this and put down a color, and let's put it to 0, 0, 0. Now, as you can see, we're still getting points because it doesn't understand. Like if everything is 0, it will just scatter around it. Like if I'm adding my paint back again, then it'll work. I think. Let me. Where did I paint? Let me see. Need to paint a little bit. There we go. So now it'll work, but if I'm gonna disable the paint now, it doesn't understand it, because normally you're gonna need to do the density scale, but since we're already working with the force total count, we cannot really do that. So we're gonna need to find another way to do that, basically. So let's do a attribute wrangle, and let's say, so if add, alright, so let's take our attribute that we're gonna use. So if at this is 0, then we're gonna we don't need that remove point. So now it's gonna remove all of the points if something is 0, and it will still work. But this, let me just need to double check if everything is working correctly. So if I'm not spawning by attribute, then it's still, yeah, okay, this works fine. So remove. So I guess that's all. That's fixed now. Let's go back to here. So now we're getting somewhere with our whole electricity setup, and we're starting to get quite a lot of controls. But I mean, you can add as much as you want. You can also like remove some stuff. But as far as it's looking now, this is getting quite quite controllable. So as you can see, this is starting to get quite a nice electricity type of asset. So let's go into the whole rendering phase. Like, how do we properly like set thickness and like make it look good? So let's start doing that now. Alright, so what I did now is I just I changed some parameters, and I ended up with this, which is decently looking electricity. Just good enough for now to just do a little render. Obviously, if you want to like go add more stuff yourself, go ahead and do that. The whole file is going to be on Gumroad, so you can get it there. But now we want to go over to the render process. I'll be rendering in Redshift for this example, but obviously you can also just use Mantra or RenderMan or Arnold or whatever renderer you prefer, as long as it can load attributes, which I think by now most of the rendering engines for Houdini should be able to do that, apart from Octane. Well, it can, but I mean, let's not talk about Octane. Alright, so let's dive into it. So let's first go in here and let's check our width attributes, so how they look, because we're gonna use attributes to create the thickness of our wires. So let's make a polywire. And we're not going to use the polywire for rendering. This is just now to visualize our whole thing. Let's put that width in here, and then we're going to get way too thick wires. So let's go into attribute wrangle, and let's do f at width times is 0.01. And now you can see we're gonna create a visualization of our current thickness. And as you can see, our secondaries are starting thin and then ending up thick because of the way that we ramped before to do like the offset type of thing, which is not what we want. So if we're gonna go in here, let's make a wrangle for our secondaries and do f at width is fit 0.1 at width, and let's go from 1 to 0, and now as you can see, now we inverted the values. So now this is that's looking quite fine. For our main branch, as you can see, because we did the whole thin to thick type of thing, which is not really what we want for now. So let's do a attribute VOP, put it in here. Let's bind our width again and bind export our width as well. And let's do another ramp parameter. And right. And now we can have some controls in here. You can promote this to a top level. Not gonna change that much myself for now, but maybe you want to change it. Personally, I don't think I'm gonna promote it up. It's just I'm gonna do some other stuff with you know what, I'm gonna do it anyway. You know what, I'm just gonna leave it like this. So because like down here I'm gonna do something else as well, which is, I'm gonna go over that now. So I'm gonna do bind, I'm gonna bind the width again, and I'm gonna bind export to the width. Oh, need to bind export width. There we go. I'm gonna multiply And there we go, multiply, we're gonna add a noise in here. We're just gonna multiply it by a noise. And I'm not sure about the alligator noise. I think alligator noise goes, I'm not sure if it goes between 0 to 1 or what, but there's multiple types of noises. So I say, I'm not completely sure what are the specifics for each of the ones, but I'm just gonna leave it to alligator noise for now. Or you can maybe promote it so you have some controls on it. So let's increase the frequency a little bit, and as you can see now we're gonna generate some nice width variation. And let's add it into our controls. So go in here and call it rendering, and let's put all of these parameters in here. So these are just gonna be our thickness. And let's do a visualizer. So I want to do a switch. No, not a swap, a switch. I want to be able to switch from just our splines to a visualized type of node. And I'm gonna make a toggle there. And let's go to the rendering. Yeah. Visualize polywire. Visualize red. So let's copy parameter and let's put it in here. So now we're gonna do visualize and we're gonna get the polywire thing. Let's also put a normal after it, so at least it's got decent normals. Now we got a little polywire thing, and this you can render them as geometry as well if you want, but it's going to be faster to render them as just splines. So this thing is going to be electricity, and this is just going to be our sphere. Alright, so let's create a redshift render node. Let's select electricity and add some object parameters, and we're going to go to strands, render object as strands, and go to cylinder. Oh, and before I forget, the strands uses p-scale instead of width, so we're gonna want a p-scale attribute. So we're gonna do at p-scale is at width, and let's put that it's a float. Alright, so now we're gonna need to make a attribute. Always check material builder, go in there, do the materials, and do a incandescent. Where are you? There you are, and just put it in surface. And for now, just put it on object, and let's also create a material for our sphere. Just maybe do just a standard metal type of material. Like aluminum or something with a bit of and let's add it on there, and let's open our render view. And we're not seeing anything yet, obviously. Right, so this is still way too thick, and that's because we should have this one, the effort width, should probably just add it in here, so it also works on the overall thing. Let's turn off the inner gravity. Take our camera, go a little bit closer. Alright. And let's go to our redshift and do the turn off override and use live mesh update. Now at least we can scrub. And go to our material network, and let's put it to temperature, and I like to have them be a little bit bluish, which is kind of nice, as you can see. Increase the intensity a little bit maybe, and let's add some random HDRI maybe. Oh, and that's an error I'm getting before, because I got my, there we go. So let's say add a light dome, add a shader, let's do maybe, let's HDRI Haven, and like grab a random one. Probably shouldn't have taken a 8K HDRI. It's gonna probably take way too long to load. Alright. So as you can see, we got decent looking electricity. So what I prefer to do when I'm rendering this is splitting up my renders, because you can already render this and it'll look fine. It's just in compositing it's nice to have like separate reflections and like things. Right, so now I want to start rendering. So I like to split this up. So what I do is, like, I have this preset render to folder. Basically what this does, it creates, like, it creates in your $job folder. So like, let's say you have a $job folder and it has like that's your global project, which you're gonna do all of your rendering in. So like all of your shots are gonna be in there. So you want a way to organize that. So what I have, like, I have a thing. So it creates a render folder, then it creates a shot name and a name of what you want to render. So let's say I want to render a sphere. I just want it to be still frame for this one. So that's gonna be still frame, and all I want to render is candidate objects. I just want to render the sphere. So now if I click render, and I'm gonna get a render folder which has like shot 10, sphere, sphere 1, and here's my render and all of the passes. And obviously I don't want all of these passes just for testing, so I just have all of my standard passes set up here, but let's just remove them for now. But as you could see, it creates folders for every pass as well, so that's quite nice. But let's just click render to disk again, and now I should only get one sheet. Yeah, so now I'm just gonna get a sphere here. So this is called render sphere, easy enough. And now I also want to do render electricity, and in the electricity, what we're gonna use, we're gonna make a take. So go to the take menu and do append the take and call this electricity, because what we want to do is we want to use render with take electricity, because what we want to do is we want to split it up in having electricity and a separate material for this that just has like reflections but not the base material, so we just can comp it on later. So we're gonna set both objects. We're gonna go into the electricity take, and as you can see, everything is grayed out, so you need to include stuff in a take. So what we're gonna do with that one is we're going to include and take the material, and we're going to, in the material network, go back to our main take, and let's create a new Redshift material builder and call this override materials. Let's put a Redshift material surface. Let's turn down the diffuse to 0, have just a random index of refraction and some roughness, and let's assign it in our override thing. Go to out network, go to the IPR, and let's link this in, right? Alright, so what we forgot to do is we need to disable all of the candidate lights because we don't want our HDRI to render with it. And we also want to disable global illumination. So as you can see, we're getting some reflection stuff, but we can, if we make it a little bit more rough and maybe want more samples. And what we, as you can see, we have this weird white thing here, and that's because Redshift automatically generates a headlight if you don't have any lights. So we need to go to where was it again? I think in, I always lose where this thing is located. Bear with me here for a second. Where is it? It's auto headlight. There it is. It's just in the main setting and default headlight creation. So if we disable that, you can see now we don't get that thing. We just get our lights and our, well, our sort of fake GI type of. It's reflections, but it's just like I don't want to render GI because it's slow. And you need to sample it quite a lot if you have like these thin lines. So let's just crank up the roughness, and also for our electricity, I think I want to have some more randomness in the I have this to a top level obviously, so let's, so now it should be a little bit more random. And I think it's not picking up on my P scale properly. Let me check. Not sure what's going on there, but it is. It just looked a little bit weird. Anyway, oh, it's the default scale. I think it's too thick. Oh, well, good enough. Anyway, so now we have this, and now we want to go to our render electricity and go to our AOVs. So output AOV. We want to have two AOVs. We want to have one for emission, so, and we want to have one for reflections. So if I'm gonna render this, now you have emission, which is just the electricity, and we're gonna have the reflection, which is this. So if I'm gonna render this, maybe I'm gonna tweak a little bit more on the look of this. So I'm gonna tweak a little bit more, and then I'm gonna render, so I'll be right back. Alrighty, so I got this render thing. So I just upsampled the lines a little bit more and changed the noise a little bit, but apart from that, it's fine for now. Obviously you're gonna want to tweak this more if you're gonna do production stuff, but for now it's good enough. Alright, so everything is rendered out, and as you can see you have the render folder, and here's the sphere. Or it should be there at least. Let me render it again. I'm not sure why it's not there. Ah, now it's there. Okay, that's weird. And our electricity, so our beauty, our reflection, and our emission. So let's open up your favorite compositing program. We're starting to use Fusion since since like early this year now. So I'm gonna do this in Fusion. You can also do it in Nuke or After Effects. So let's drag our sphere in there, and turn our LUT on. Let's put it also in here. All right. Let's just turn off the. Right. So let's merge on our electricity. So where's this thing? Electric. So take the emission and take the reflection. And alright, so do a channel booleans and add our reflection on there. Do nothing. So now we're having, and let's turn down our right. So that's our reflection thing, and do another channel booleans and add our little electricity here. Alright, so what I can then in comp you can experiment with is, like, I like to do sort of a erosion thing. So then I'm just gonna make them a little bit thinner inside of comp. Maybe a bit too much. So this way you still have, like, by splitting it up, you still have control over, yeah, over whatever you wanna do in comp. You can do like a brightness contrast, and you have like the gain thing here. So maybe put down the gain a little bit, and then do like a noise, so fast noise. And obviously this is also stuff that you can also do in your shader. But it's also nice to just tweak it inside of comp a little bit. So now we have this this noise thing, which we can receive rate to like change the it's gonna change the intensity a little bit across the electricity thing. I'm not liking the this too much, so let's blur this out maybe a little bit. And let's mask this. We need to put it in this one, obviously. Alright, so now it's masked a little bit. Still not quite digging it. Maybe add like a glow. I don't really like the way glow looks overall, but it can, I guess, add a little bit to it. I don't like to do it too much. Maybe a little bit. And then I guess you can gain, and maybe we want to like color correct it a little bit, make it a little bit more blue. I don't know, I'm just Like right now, the whole compositing thing, you should just like this is not gonna look great now with just this plain sphere. But it's just to get like a good like an idea of what you can do with like this technique overall. So if you like just apply all of this like all of these techniques, then you should be able to get quite decent electricity type effects. So like increase the blur a little bit more here. Maybe I want to maybe I want to and, you know, yeah, like I don't want to spend too much time on like tweaking this whole thing, but like you get the point on how you can like make this look good if you want to. Another thing that's nice, which you can also do in comp, which I did for a little bit, if you have like if you want a little bit more chaos perhaps in your electricity, what you can do is you can, no, not disparity, displace, you can take another noise, not a merge, just another noise, and just displace it a little bit with the noise. So if I'm gonna like maybe the contrast a little bit less, but see it rate a little bit up. So that's just like extra controls that might be nice to get in comp. And still put a little glow there maybe. So yeah, that's basically how you can do electricity, and like if you tweak this, you can get quite cool effects. So let me maybe go to like if I'm gonna go to, for example, this is obviously all still work in progress, but like here's some electricity stuff. Which it's, I mean, as I said, all these shots are still work in progress, but they like they should give you a point that it can look much better than this, because this is the same techniques that I used like in this one, I think. Oh, then that's just another version. So like I guess I only rendered a PNG for that one. Let's just open it in here. Like this one, same idea. As I said before, this is all still work in progress. All these shots. Like the whole film is gonna come out later. But yeah, you should, like, I hope you can make some awesome stuff with this. If you make something cool, just drop me a line, show me what you made. And I hope this was useful. I know it's been quite a long tutorial, but like I As you know, I like to ramble on and go into detail on like what the how and why on everything. So I hope this was useful, and we'll talk to you next time. Bye.